Hey guys, this video is part 2 in a series, so watch the first one first. I'm going to play some clips from the first one so that you get context, but they're going to be out of context. If you don't understand it, go watch the first one. Watch the first one now.
Oh, great. God damn! Crocky, we're in hell! Yes, that's why you clicked on this video. I didn't click on anything. That circle of hell is for practitioners of deception, fraud, and thievery. They added a 2! Don't look for pattern, it's not there. Anyway, you guys want to play cards with me to pass the time? Here's the code. Yeah, you can't read that. So here's the normalized code. You can't read that either. Characters by what? Finally, I can marry someone decent. My old idiot husband Carl couldn't even figure out Malbolge Unshackled. Malbolge on what now?
Put simply, a Turing-complete programming language is one that is able to calculate any problem that any other computer can calculate. Most programming languages you use are Turing-complete. When Malbolge was first designed, Turing completeness was not a goal. In fact, when Andrew Cook was generating his programs with his search, he was surprised at how none of them entered infinite loops, implying that Malbolge wasn't Turing-complete. After all, since Turing-complete systems are able to do infinite loops, one would expect procedurally generated Malbolge programs to have them. Also, even if Malbolge could do infinite loops, it still wouldn't be Turing-complete, since Malbolge has a fixed memory size of 59,049 machine words. In order to fix this problem, Rajan Johansson invented the one and only Malbolge Unshackled. The main change is that the size of a machine word is no longer simply 10 trits, but the lengths are unbounded, and since the registers are now unbounded in length, Malbolge Unshackled no longer has a fixed number of machine words. For the crazy operation, the first trit of a value is extended to repeat infinitely to the left, which allows Malbolge Unshackled to perform the crazy operation on values of different sizes. For rightward rotation, the width of the rotation is random at the start, and it changes at runtime. The width of the rotation changes too, in a fairly unpredictable way that is dependent on the interpreter you are using. It tries to stay around the same size as the data pointer register. Lastly, for the print command, the value printed must now be exact. It no longer does the modulo with respect to 256. These changes make Malbolge Unshackled way nicer and easier to program in for the user, turning the Hello World program from this regular Malbolge program into this Unshackled program.
Hey, what's going on here? Where are all my employees?
According to my sources, they are happy and healthy and normal and alive.
Well, that doesn't seem true. Where are they? Sorry to bother you, Mr. Boss, but they all died? Well, revive them! Or else! I'm trying. Well, seeing as they're not alive yet, you're not trying hard enough. Now get back to work! Oh, and this doesn't excuse you for making sure to count all of the blades of grass on my lawn.
Anyway, back to Malbolge Unshackled. Since the number of trits in a word is random and changes at runtime, programming in Malbolge Unshackled is way more difficult and better and easier than vanilla Malbolge.
And Carl the crocodile can't understand this super easy language because he's dumb. It's Cayman! Begone, foul creature! Hi-ya! Well, that was an interesting intro. Anyway, Malbolge Unshackled. It's probably the absolute most difficult programming language that has been invented so far.
By removing the constant machine word length, Malbolge Unshackled programmers now have one more thing to keep in mind when writing code, on top of dealing with the encryption, the crazy operation, and the entire fact that it uses trinary. Malbolge Unshackled was proven to be Turing complete in 2016, when Matthias Luther wrote a brain interpreter in it. And since Malbolge Unshackled was invented in 2007, that would mean that it hadn't even been shown to be accomplishing its main goal for 9 years. But there is actually an even more interesting demonstration of Malbolge Unshackled's Turing completeness. This one was created in 2020. So, you know that pandemic project that you made because you were locked in your house due to COVID and you were bored? Perhaps you even made a video about it? Yeah, that was nothing compared to Malbolgelisp.
Malbolgelisp?
Yeah, you heard that right. Malbolgelisp. Lisp, for those of you who don't know, is a family of Turing-complete functional programming languages. And someone going by the username Paleologos, whose real name I would definitely mispronounce, made an implementation of Lisp in Malbolge Unshackled. Oh, and did I mention that she was 16 when she made this? Yeah, I'm gonna go throw my video generator in the garbage now. But anyway, this 164 megabyte Malbolge program, yes, it's that long, demonstrates that, yes, Malbolge Unshackled is Turing complete. Though for this to be possible, Malbolge needs to be unshackled. Otherwise, the finite amount of memory present in regular Malbolge makes these types of programs impossible. But when it comes to Malbolge Unshackled, the Turing completeness demon has been slain.
Well then, if someone can write Malbolgelisp, then maybe we can write a simpler program?
No! Too risky.
Well, we have to try something.
Wait a sec. I think I have an idea. It might be crazy, but there's about a 5% chance it would work. Here, take this fishing pole to the ocean above the Mariana Trench, and see if you can pull them up from there.
Mr. Seatail, I know that there's a stalk of cabbage where your brain usually is, but that sounds dumb even for you.
Well, it's the only plan we have, so I think we should try it.
You're all stupid. I'm coming along to watch you all fail. Okay.
Wait! You've forgotten me!
Walk out the door, you see someone that you know and they ask you how you are, and you just have to say that you're fine when you're not really fine, but you just can't get into it because they would never understand.
So there are several methods to printing text in Malbolge. The easiest way is to use a generator, because you don't have to actually think. But that's lame. What I want to try doing is writing Malbolge code mostly by hand, because I love using technology to mentally torture myself. So, to print text, we start by jumping to a position where the code pointer is ahead of the data pointer, since trying to change the data pointer while the code pointer is already there may cause the program to crash. Luckily, at machine cell 40 is in base 10 by the way, we are able to have the value 41 as a legal command. So we jump the data pointer to 40 and the code pointer to 41. Now we have the code pointer running commands and the data pointer following it.
Nice, but what can we do with this?
Well, we can use this method that I call the fisherman's method. Because we're fishing for characters. I don't know, it made sense at the time. I probably don't even have the naming rights for this. The only way to get a symbol into the accumulator, besides inputs, is through right rotate on the data or through the crazy operation. As a result, it's difficult to actually control what ends up there, but luckily, the ASCII value doesn't need to be exact, since whatever the accumulator is gets moduloed by 256 before being printed. But I made a tool that makes it a lot easier to find the symbols. You simply input what the accumulator is right now, and then you get what symbols will be in the accumulator if we did the crazy operation on the data pointer cell. For example, here, with the accumulator being 0, and running the operation on a cell containing a $sign, we get the letter T. When does the data cell contain a $sign? Well, after a plus gets encrypted, of course, and since the data pointer is following the code pointer, that means that if we do the crazy operation after passing over a plus in plain text Malbolge code, then the accumulator will contain a T, which can be printed out.
So, how do we get a plus into the code? We only have these opcodes, and it doesn't seem to be consistent.
Well, we simply add a bunch of no-ops until the code pointer mod94 function makes the plus be the no-op symbol, and then we run the crazy op. And that's how we can sort of control what symbols are in the accumulator, so we can then print the accumulator using the less than command. Hooray!
But this method doesn't allow all of the letters to be chosen. What do I do if I wanted to print the word hi and there's no H there?
Well, you do the crazy operation anyway, of course, and hope for a better set of letters to no-op to. It's like fishing. I guess. I don't know. I don't really go fishing. But yeah, using this ridiculous method, I can now write text using Malbolge without using a text-to-Malbolge generator. Using Matthias Lutte's Malbolge debugger, the programmer can easily switch between the normalized and actual Malbolge code, which lets you see what the data looks like at any given time. This is nice for knowing when the encrypted Malbolge code actually contains the right symbol. Also, the numbers here are written in base 9 for whatever reason. I guess that's because it's easier to convert from trinary to base 9, but sometimes I find it a bit inconvenient. But still, this debugger is one of the nicer debuggers for Malbolge.
Well then, we have the fisherman's method, and we're right above the Mariana Trench. Let's do this.
Agreed.
Whatever.
Honestly, I thought you were going to succeed anyway.
Shut up, shut up, shut up.
Phew. I don't know what got into me.
Neither do I, dude. I'm just glad you're back. You're back, right?
Carl, you doofus.
Of course I'm back to normal, you wonderful Cayman.
Hey, quit with the sentimentality.
Man, was I always that frustratingly ugly and irritating? Yes, you were. And still are. Well, that doesn't matter. There's still unfinished business to do.
Oh my god, you idiot!
Hey, Paperclip! What did you do to that big green guy? I'm sorry, but that information is purely confidential. Would you like some help in losing your desire to care about him?
No, he was right to warn me against unshackling you, and I was wrong. So you know what? My first appearance on this YouTube channel was related to the 99 bottles of beer song, for whatever reason, and that's how I'm gonna take you out.
Oh no! Would you like help writing a strongly worded letter to me instead? So the first people to actually code in Malbolge and write decently sized programs in it were researchers at Nagoya University in Japan, led by Hisashi Izawa. They devised LAL, a low-level assembly language developed to compile into Malbolge, using cycles similar to those on Lutte's page. As a result of their research, Izawa and his colleagues made a 99 bottles of beer program. That is very long. Very long. It's still going. Additionally, Matthias Lutte invented Hell, the hellish low-level language. Hell is another assembly language that compiles into Malbolge. Here's the cat program written in Hell. It compiles directly into the cat program that I showed in the previous episode. As you can see here, the cycle to input and then immediately output that input is used inside of a loop in order to create a cat program, which is a program that copies the input directly into output. This one does it for all eternity since it doesn't halt. And yes, Malbolgelisp and the Malbolge brainfuck interpreter were written using tools like this as well. Because programming in vanilla Malbolge in any way that isn't just printing text is straight up impossible.
But does this really long 99 bottles of beer program work? Well, let's test it out!
Come on. Move it! Could you be any slower? And you've had your blinker on for the last 5 blocks.
Whoa. I guess I'm not as immortal as I thought. But I've been around since the beginning of the universe and am continuing to exist, so I think I can still call you guys puny mortals. You're welcome. Well then, you guys actually all did die way too early, so because I'm nice, I guess you can stay on Earth for a while longer.
Cool. And, Obfuscate, were you always the ruler of hell?
No, I'm not the ruler of hell. And that wasn't even real hell. I was 1,000% protecting you from the real thing. But anyway, puny mortals, have fun with your second chances. Now get out of my sight, all of you! And with that, we have made it to the end of the long-awaited Malbolge video series, because I split this into 2. Anyway, thanks for watching, and I'll see you next time.